So the second half of section 4.6 is dealing with something called the discriminant. Now, we've already kind of talked about it, but underneath the square root of our quadratic equation is something called the discriminant. And that can actually give us important information about our quadratic formula and how it graphs. It also tells us the number and type of roots that we can get. So, this is what the discriminant will tell us. If we get b squared minus 4ac, and it's some number that's greater than 0, meaning it's positive, and it's a perfect square. Some examples of perfect squares would be like 81, or 121, or 256, something kind of like that. Those give us rational roots, two rational roots, meaning they're going to be whole numbers. Okay, those are going to be whole numbers. When we get our discriminant to be greater than 0, meaning it's positive, but it's not a perfect square, like 15 or 41, then I'm going to get two roots, but they're going to be irrational, meaning they're going to be decimals. Okay? If we get it equal to 0, we kind of talked about this before. When it's equal to 0, you get one rational root, and that's because your vertex is located on the x-axis at some point. That's why you have one rational root. And then finally, whenever you get your discriminant to be a negative number, you're always going to have two complex roots. And those are going to be complex conjugates. So for example, if you have 2 plus 3i, you automatically know your second one is going to be 2 minus 3i, or something like that. And you might have decimals with your complex, and that's totally fine too. But that's just what is going to happen when you have it be negative for the discriminant. So let's look at an example 5. So if we look at example 5, it says to find the value of the discriminant for each quadratic equation, then describe the number and type of roots in the equation. So if we have our discriminant to be b squared minus 4ac, I need to make sure that my quadratic is equal to 0, just like before when we were solving with the quadratic formula, and I just input my numbers. So b is going to be negative 11 squared minus 4 times 7 times 5. And when I put that into my calculator, I find that my discriminant value is going to be negative 19. So since it's a negative, we think back or we look back to our notes. Anytime my discriminant was negative, I was going to get two complex roots. Letter B. So for this one, I'm going to, again, start with my discriminant, b squared minus 4ac. So b is going to be 22 squared minus 4 times 1, because, again, we have 1 in front of the x squared, and 121. I put this into my calculator. 22 squared minus 4 times 1 times 121 equals 0. And so since this is equal to 0, we said that this has a distinct answer, and that was going to be only one real root. Okay? So that's going to be equal to our one real root. Here's two guided practice problems that you can try now. Now we looked at example 5a. And so what I'm going to do is I'm going to say b squared minus 4ac, and I put in b as in 8 squared minus 4 times negative 5 times negative 1. So I put this into my calculator. 8 squared minus 4 times negative 5 times negative 1. I end up getting 44, which is not a perfect square. And so since it's positive, not a perfect square, two irrational roots. So finally, this is what we've covered so far in chapter 4. There's about 4 different methods. Here they list 5 things, but really it's 4 different methods to solving quadratics. There's graphing, and graphing is the most effective when you have a guess or you're not quite sure, or you want to find kind of what your roots are going to be. And most of the time this is good, but it's only good when it's exact answers. And so it's really hard when those are decimals. Factoring is another way we can do it. And that's really good, especially when we have a constant term of 0. And so, again, factoring is another way that we can do it, and we can get an answer. Now, square root property and completing the square is kind of the same sort of deal. And so what you can do is you can essentially make it so that you have a perfect square trinomial on the left. You can square root both sides on the right. So I would assume that this is pretty much the same thing. And I know it says completing the square always works. I would say that, again, this is kind of a sometimes problem. Now, if you're ever stuck in a rut and you're not sure how to do it, this last form that we did, the quadratic formula, is always an effective way. And it's especially the most effective when you have an example like this one where you have decimals as your coefficients. That's especially when it's going to work the most. And you're going to get some kind of messy answers with it sometimes, but it is the most effective way to do it. And if you are ever lost or not sure how to solve it, make sure it's equal to 0 and then put it into the formula.